Imagine that you are a fish, and your professors are fishes, your teachers are fishes, and your professors, there's two groups of professors, and the one group says that there is no such thing as water. And the other group says, yes, there's water, and that's what causes all the things around us that we see happening. And you're a fish, and they're all fish, and the group that says, yes, there's water, they say that if you wiggle your tail in the water, that's what's propelling you forward. And the other group of professors says, no, that's not what's going on. It's not that the water exists, it's that when you wiggle your tail, that's what causes the motion forward. It's more like a state of reference or something like that. Now, of course, you're all fish, and you're in the water, and whether you acknowledge the water or not doesn't change the fact that, of course, there's water, right? But how would you know, if you were a fish brought up in the water, that the water even exists? This segment is on the topic of inertia. Inertia of rest and inertia of motion. With inertia of rest, what you've got is, you have this, well, say you have this object, it could be any object. And with inertia of rest, it's hard, say this is the object, it's hard to push and get this object moving initially. That's inertia of rest. It has to overcome the rest state of it, is what they would say. Inertia of motion is the opposite of that. Inertia of motion is the object's already moving like this, and it's hard to stop it because it wants to keep on moving for some reason. Why would an object be hard to start, and why would an object be hard to stop? Well, that's inertia for you. Like I said, if you were a fish and you were in the water and you didn't know anything about inertia, you didn't know anything about water, you wouldn't understand why perhaps you can push against the water and why the water pushes on you. You might just think it was a fundamental force of nature, that the water didn't exist in a real physical form, it was just a physical rule. But water is not a physical rule, it's a real thing. Let's demonstrate this. And a nice, easy way to demonstrate, you can actually feel that the ocean that you're in. You're actually you're in an ocean of what I would call matter. And matter, or whatever you want to call it, this ocean that we're in, this stuff that we're all in, little pieces of stuff. We're like a screen door to this stuff. Most of this stuff just passes right through us, like we're a screen door. Like, say this is the stuff and this is you, and most of it just kind of passes right through you as you go along. But some of it, you get to push as you go along, even though a lot of it goes through you. And some of it you push, and some of it will push on you as you go along, just like you're a fish in water. Now you can feel this ocean that you're in, this ocean of matter that we're all in, simply by going like this. Now, I felt the blood rush to the tips of my fingers, and I felt the, well, I also got dizzy too. Now, why did the blood rush to the tips of my fingers when I spun around in a circle really fast? Or if I even go like this really fast? I don't have to spin all the way in a circle, I just go like this. I can feel the blood rush to the ends of my fingers. Why? Why? Why do objects want to stay in a straight line motion? Why, when I put them around it in a curve, does my blood go out like that? It's because of the ocean that we're all in. And this happens because when the blood is going like, here's the motion like this, If it's going like this, then the blood wants to keep going straight. It's a fluid in my veins, so it wants to keep going straight. But instead of being able to go straight, when I pull it around like this, when I pull it around like this, then I'm pulling it back again. So it had a motion, it wanted to keep that motion, and then I pulled it back in. But why did it want to keep that motion? Why did that happen? I could just say it's a fundamental force of nature. But I know better. You know better. What's happening is that this ocean of matter that we're pushing against is pushing on me too. And what's happening is, when I start a flow in this matter, like this, the blood just is pushing on this matter too, and setting up a flow in this ocean. So the ocean's flowing behind it, and then when it tries to change its direction, the ocean keeps going and takes the blood along with it for the ride. So the blood rushes to the ends because it's being pushed along by the ocean, the water that we're all in. This proves, beyond the shadow of a doubt, that you can feel this ocean that we're all in. It's a very, very simple, experiment that anybody can do. So that's inertia of motion that's causing the blood to rush to the fingers. Another way to think about, to cover inertia of rest, you have an object in an ocean, and because it's in an ocean, because there's stuff all the way around this object. Here, let me get an object. So, inertia of rest. Imagine that there's an ocean of stuff around this object. Could be any object. And the object, when it gets pushed, what happens is, when you're just starting to push it, you're pushing not just against the ball, but against the ocean of matter. And you have to establish a flow in that matter. Until you've established the flow, you're bumping up against the ocean. And once you were bumping against the ocean, but once you push on the ocean starts flowing around it and through it, and it becomes a lot more fluid. Once it starts going, it's starting to establish a flow of the ocean behind it, and the stuff that was stuck around it and on the front of it is starting to flow around and through it as well. So this object starts going like this, and it's starting to flow through the ocean. Now that it's got a flow established behind it, it's hard to stop the object. So, inertia of rest, hard to start, and inertia of motion, hard to stop. All because of the ocean that we're all in. Because we are fish in a giant ocean of whatever you want to call it, an ocean of matter, an ocean of just simply stuff. Another thing that we often did when we were kids is run around in circles inside a swimming pool and kind of try to make a whirlpool inside the swimming pool. And as you started up through the water would carry you. The water would stop you from going around in circles in the swimming pool. But once you got it going, then the water would carry you along for the ride. And just kind of stop yourself and just kind of drift along as the water pushed you. Initially when it's hard to start running through the water, that's inertia of rest. But once the flow of water, once you've established that flow, then that's inertia of motion. So inertia of rest and inertia of motion are simply just starting and stopping flows in this ocean of matter. Inertia of rest is trying to start a flow, and inertia of motion is trying to stop that flow that's already been established. And that's it. That's as simple and as all of the explanation that inertia ever needed. And the reason is simple. All other parts of physical existence is made up of parts of this ocean. Like, for example, an individual atom that we're made up of, you have like a nucleus, which is just a collection of balls, you know, balls of this matter. You got this nucleus, and then surrounding this nucleus of a single atom that we're made of, you have these other much smaller balls that are out at great distances. Like here's the ball for this nucleus here. You can see it's much smaller. Actually, this ratio isn't even right. This is actually much smaller, and this distance is actually much greater. But you can see that we're mostly made of, what people would think of as empty space. Because the electrons, yeah, they're here, and they're there, and they're there, and they're there, and they're there, and they're there. Anyway, but it's not that we're actually made of empty space. No, in fact, space is not empty. It's full. It's full of ocean. And there's even smaller pieces around the electrons that act as buffers, and even smaller pieces around those still, and those still, until even the electrons themselves have like a cloud of stuff around them, like a buffer. And that's why they space themselves in very particular arrangements. Because of this buffer of matter, it's like the electrons have what you could call a gravity. And so, anyway, the nucleus does too. Only its gravity, part of what it grabs around itself, is the electrons. But as you can see, there's a lot of space between the larger objects that are better connected and the ocean that we're all in. And so it is like we are a screen door where like as material flows out, other material flows in. And that's how we're like a screen door. That's how the ocean of matter can push on us, by pushing on our electrons and our protons and our neutrons and the nucleus. The ocean can push on us, but it can also flow through us, because there's a lot of space there that's very movable. Not so much in close to the nucleus, but more like towards the outside. And the spacing even between atoms, the ocean can flow between there as well. The ocean can flow through everywhere if given enough push, but about the time that the ocean gets violent, and there's some violent waves in this ocean, it can actually disconnect the electrons. It can actually disconnect and destroy atoms. In processes like burning and such. And that's it. That's as simple as it is. And it's all just a game of marbles fitting different places. This ocean that we're all in, this ocean of matter, really explains every fundamental, what was thought to be a fundamental force of nature. It's not that nature has fundamental forces like gravity and inertia and electric attraction and magnetic attraction and repulsion and such. All these things are just made up concepts to explain happenings that we didn't understand because of this ocean that we're all in. But it turns out that all these things are explainable if you believe there's an ocean.